Star of the show's here. We can start. Everyone say hello to Derek and Norm. Oh my God. If I had any nerves, I'd be nervous now. No, it's Norm with an exclamation mark. Always. Hello, Mr. Nuttinger. Beer helps with everything. Right, let's crack on. People are coming. And I'll get the boring bit out done at the start. Right. Blah, blah, blah. Hey, Tidor, how are you? Okay. What is Grove? Hi, Danny. So Grove is just a connector-based system, and it's lots of little cheap boards. So it originated from SEEED Studios. Let me see if I've got a website with it here. Hold on. So this is the Grove ecosystem. Boop, 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 bop. And you can see there's loads of stuff. And it's very cheap. I'll go through prices. And there are other places that do it. So in America, you have this thing called Pico Bricks. And Pico Bricks, that's all Grove stuff there. Those little doodahs. And you've got M5 Stack. M5 Stack, that's all Grove as well. There's essentially just a connector standard. So here's a connector standard. So you have digitals, analogs, ins and outs, digitals, ins and outs, UART type stuff, transmit, receive, I2C. What's PMOD? Okay, so that's generally where we're going with this, is different things with these. So first of all, I'm going to go straight into the demos because slides are boring, and that is a cue for my camera to decide it doesn't want to stream. Very tiresome. Bear with. Been on for ages. I think probably just overheat. Sorry about this. As I was expecting, I was going to get issues. There we go. Okay. Let's have a look at our demos. Bump. Got a little screen here. Bleep. I'll get the aspect ratio. So I'll do all the quick, boring ones first. They're all the digitals and the like. So let's go straight in. And we got our LED socket. So what I'm doing, if you go to the Grove ecosystem, they have loads and loads of Python and Arduino examples. I'm aiming to make something similar in the world of LabVIEW examples. So I'm going through, buying lots of hardware and wiring it up and writing a little VI so that we have this whole setup. So the very, very start of our lives in LabVIEW is the LED, turning the LED on and off. We all like that. So let's do that. On, off, LED. All right. That Lego is brilliant, and it's really cheap as well, mate. It's only, I'll go through prices later, but it's like less than $1 for each one. It's wonderful. So yeah, and it's good quality as well. So there's our LED. So we have I've done other digital inputs as well. So we've got fan. Let's do, we've got a relay. There's a relay. It's all very. So stick the relay in the other one. So this relay is all of £2, I think. So what's that? $3 to you Americans. And I'm not working it out for anyone else. So click, clock, click, clock. Oh, can't see the light. Maybe you heard the click. See the little red light on the relay? So that's cool. All very simple. So I'm using the very lowest level of driver that I can for this. Eventually, this is going to get wrapped up in a bigger sort of driver set to make auto discovery. But because I'm doing this as test purposes, I just really want the Visa down here. So you'll see a pretty direct line between these and the Visa. That's because I just want to package up the Visa message and send it to Derek and say, "That's not working, Derek." I did that last time, and it was actually because I'd blown the Pico up. What else we got? Oh, this is a MOSFET. So we came out. The MOSFET it's slightly more interesting because this is a switch that you can do some funky things with. Oh, camera's gone again. It's going quicker and quicker. I'm wondering if there's something that alters the temperature. Bear with. So this is the MOSFET. Yes. It will have better. It will have better everything, really. And like you say, it will have the capability to use Arduino firmware where this won't, and things like that. But like I say, I really just want to. This is more about showing people how to do drivers and that, using it. So I'm just going through all the boards. So let's have a look, see if I can get the thingy on again. Hold on. Get my camera off. I'll give it a little bit of a rest in case it's overheating. Okay, right, that's ready to go. Camera on. USB streaming. I don't know what keeps going off. I wish it wouldn't. It's very annoying because I've got the lighting all set up and everything very nice. So this is a MOSFET, and if I turn the power supply on, I'll move this over here and move that out of the way. You can see I'm drowning in cables here, which is all adds to the fun. And now I run this. What have I got it plugged into? 16. There. Run him. I should have 13 volts, but you can't see it because that's in the way. Hold on. Beep. All right. Let's move that over. Going to be a constant fight for real estate here. Bonk. Not much. Bit of noise. Just because it's high impedance. Could do a resistor of some description there. And then 13 volts. The thing is, you can switch to the little MOSFET at 5 megahertz. So it's quite a useful little beast. A bit of switchery. These are. I'm going through the most boring ones first, and then going upwards. There's a fan. I'm not going to demonstrate that. He whirs and gets in the way. Okay. All right. Next, do something a bit more fun, shall we? Oh, no, let's do something slightly more boring. I like switches. I quite like my little switch VI as well. So MOSFET off. Now, if you see what I'm doing here is I'm plugging hardware in and out. So there's no breadboards. I found breadboards were a hazard in my hands, and I kept blowing up things. So we go to digital input. We go dual buttons. Let's go COM 5016. Bonk. So he's running, and if I press a button, we move it over so you can see my fingers. Press a button. Beep. Bob. Oh, I've got the red and the green on the wrong one. Bad demo. If I hide it like that, nobody ever see. Okay, so I'm pressing red. I need to swap the covers. But there you go. You get sound effects with everything. Okay, so that's that. And I'm trying to link this so you can link to the hardware. That button is another £2, I think. So then you got single buttons, you got motion sensors. Probably not going to bother too much with them because the I2C stuff that I really like. But so he done analog input, light sensor. Okay. Somewhere up here I have a light sensor. Oh, I've lost my light sensor cover. So this one goes into the analog out. Pull that back there. And all he is a little analog light sensor. So if we run him, so the analog in is 12 bits natively. So it's not the best, but it's pretty fast. I had something really good for covering up the light sensor. That'll do it. Okay, so if we run the light sensor now, it runs maximum because it's got lights shining in its face. If I stick a cover on it, boop, you can see it goes down to 0. Can't see because I've got the thing in the way. There he is. There's a little light sensor there. And you'll see me stick my thing over it, boop, back down to 0. So that's cool. Shows you analog inputs doing analog input stuff. There's a twiddly pot as well, so we could do that. Rotary angle potentiometer. Or as we call it, a twiddly pot. Where's that? Oh, he's there. Bonk. Let me get him out of the way again. Oh, and the camera's died again. Oh. It's very frustrating because that's been on all day. That's probably what the problem is. Right. Oh, I'm going to get good at that. So twiddly pot. So there's the twiddly pot there. I could turn the brightness down already. So again, same thing. Twiddle. Ah, plugged him in the wrong one, haven't I? Pot of twiddle. Done. What else we got? Oh, we got a sound sensor. So sound sensor is something I'm using in my training course. Just as a means of getting data in, really. So I'm doing like a demo of it. Just it records loudness, not sound. That's it there. So let's do that one. Bonk. So let's run that. Hello. So that's it doing its thing. So it's actually quite a good training. Oh, camera's gone again. It's quite a good training method, just for sort of logging data, and I'm using it to train sort of database stuff. So loudness in a room, that kind of thing, and just log it to a database. So it's quite a handy little analog toy for that. I know the camera's gone off again. So if you've seen this before, I'll just let the camera cool down a thing. I wonder whether it's getting hot. So the PWM plugs into output on our boards. It plugs into the A0, A1 and A2 connectors. Bear with again. If I can get through this without swearing, I deserve a medal. I can feel it welling up inside me. Bad language will appear. Okay. So I'm very pleased with my little piano. It was one of the first demos I did. So there's the sound buzzer. I'll move my speaker over so you can get the full glory. Full glory of pianoing. Okay. That's my Hammond organ. Let's have a look at the code for him. Again, I've gone as dirt simple as I possibly can. So I'll just, it's frequency, duty cycle into the PWM. Not doing anything. So there's a servo that works in a similar way, and the passive buzzer is actually the version that will be available, which tells you how to do everything in the world of passive buzzers. How are we doing? 8 minutes past. Good. Got plenty of time. All right. Let's have a look at I2C. So I've whipped through the very, very simple stuff. So that was digital outputs, digital inputs, analogs, pulse width with a description of what the pulse width modulation is. Look at that. Beep, boop. And now let's talk I2C. I2C there's an awful lot of devices out there. Awful lot of devices. And it gives you massive amounts of capability. It's really astonishing how much we can do with this. I think we're just discovering it. So I've gone and bought loads, and I'm going through them. It's a simple waveform, and if I get time, I'll go through how to do a driver and how I've been sort of hacking it all together. But essentially, what you're looking at is a clock and then data, and it's not much more than that. So you're limited in length of cable and all that kind of stuff because it's designed to be talking to chips on boards. So you're not going to get a great deal of distance. There are extenders and things like that you can get, but it's incredibly powerful. I'll give an example of that power with this little board here, and hold on. What have I got else to say? Oh yeah, I've got demos now. Cool. So I'll do this board first, just because it blew me away. So there's here a little board. It's got 4 3-amp relays. You can get SSR ones as well. And it's addressable. So part of the command, it's got a little ESP thing on it. And it takes commands. And one of those commands is to set its I2C address. So you can actually set 127 of these to run off of one of your I2C outputs on a Pico. These are £10. That's 4 channels of 10 amp, 250 volt AC switchery that you can have on a Pico. It's just the cost per switch, if you've done switching systems, is trivial now for this. So let's have a look at it. Oh, Jesus Christ. Let's open him up. Bonk. So there he is. Wrestle with this. I'll give up and put my other camera on in a minute. Okay, so what we have with that is your relays there. Move it over there. So let's just run him. Bonk. He's not working. What is that? Oh, I've got the wrong. I'll bear with. Helps if I put the wrong right visa resource in. There we go. Boop. You can see the little light coming on. And that's we'll have a look at him in a bit if I get time to show you how it's all deciphered. The code is trivial on this, which is why it's quite a nice I²C example. But you can also set the address and upload the address, so which is really rather nice, and it stores it in permanent memory as well, so which is rather cool. So, for example, when you press a switch, it just creates a number. So it gives it a command channel and a number. So that's the command, which is a registry, and then you're just feeding that registry that number. And that's all there is to it. And actually, there is an 8-channel one which you just send 2 bytes. So very, very similar. So again, you could have well over 800 switches on a Pico, which is kind of incredible. So you've probably all seen the camera, which is one of the first projects we worked on. Norm has been doing that, and I've been busy nicking all of his clever stuff. Oh, god damn! I don't really matter. You don't need it for this. So, if I run that, you'll see the camera. So that's me. Hello, me. Ooh. Which is a nice lesson, this one, because it teaches us all about bit of signal DSP, bit of signal conditioning, that kind of stuff. That's all very nice lesson material. That's the thermal camera. Bonk. Next, just going to leave my camera a little while to cool down. So while we're doing that, we'll do boring stuff. So there's a temperature and humidity sensor. Again, it's good data. So that one there. Oh, that's because it's the thermal camera. I like it. Should we try plugging in the humidity sensor rather than the thermal camera? Okay, that might do us a bit better. Bloop. Okay, so you can see it's quite hot in my room, and it's not too humid today. It's actually nice. It's about 50. So the weather in the UK has improved radically. So that's cool. I'm going to just leave my camera off just a little bit longer, just in the hopes it'll stay on for a bit longer afterwards. But they also do unfortunately, I've lent the module out, so I can't demonstrate it. But if you wanted some analog inputs, because 12 bits is not enough for you, this here module there's a driver for, and you get 4 single-ended 16-bit digital inputs. And they go all right. It's samples per second, 860 samples per second. Poots along, and it's programmable gain array. It's a nice little device. I wish I hadn't given it away now. But to imagine it, just so that we can imagine it, there's also a thermocouple one, which I do have. I haven't given that away. So let's bring him up, and I'll put the camera on so you can see what I'm doing. Temperature, thermocouple. Bonk. Yeah, yeah. These are actually quite nice little chips, the ones that they've used for these. So a little thermocouple, and I know we got a T-type. So if I put my sweaty palm on the T-type, a little bit of noise there. Got zappy fingers. The trouble with thermocouples, they've got an open end usually. They pick up a little bit of noise. Anyway. Hot, hot, hot. This is what I am. And yeah, see, that's again quite nice. So that's only like, I don't know, $15. And you've got thermocouple. And it's quite a good thermocouple. You know, you got all the different types here. Take an R type, for example, which is platinum rhodium, if I remember my thermocouples, then that's probably worth about 100 of the things that are monitoring it. So that's quite cool. Let's see if I can get the camera going for that. We shouldn't have left it on. Yeah, so there's a little thermocouple there. So yeah, it's a nice little module. I like him. He's got a cold junction on him and all sorts of good stuff. So that's quite a useful one. Now, the one I really like, which is going to be very handy if this lasts long enough for me to show it, is the gesture sensor. So this I'm using to train or teach state machines. So you can build a state machine where you use the gesture to move out. So it's like, you know, and these gesture interfaces are quite handy if you don't want people pressing buttons and stuff. So I'm plugged it in. Some of these I2C boards reset the Pico when you plug them in, I've noticed. They're not hot swappable, I think the term is. So, is that running? Yes. Okay, go left. Left, go right. Right, left. Down. My hand's in the way. Up. Down. Oh, he's got a twiddly one there, twiddly one there. Let me zoom back out a bit. Yeah, there's something going on there. Let's see if I can actually get it to pick me up. That's right. Right. Come on, left. There we go. Up. Down. No, it's picked up quarter. Down. You can go. Back up. I am. You have to get used to it. It's not very good because there's cables in the way at the moment. But it's pretty good. It's you could if you stick it on a wall and it's you face it in a it can do the clockwise really well and the anti-clockwise, but you have to get it right. And it probably doesn't like the light shining in its face either, but you can see it going. Let's turn the light off. See what we get. Darkness falls. Oh, look at that. Yeah, don't like the light. Down, up, twiddle to the right. Come on, twiddle to the left. There you go. So yes, that's quite a cool thing. I think I like it quite a lot. That. So yeah, I'm using that for teaching state machines. So so you go through a user interface using the twiddlers, as it were. So that's quite nice. And this gyro. Let's see if I can find the gyro. Oh, let's do a bit of LCD. You've probably seen these from what Derek has displayed, but I'll do it for anyone who hasn't seen it. Oh, I'm sitting down. I stood up. See why I got all the. Come on, get in. There we go. All right. So you can see it's quite difficult for the camera to get its thingy sorted. I'll put a bit of light on there. Yeah, there we go. A bit of contrast. So if we do the LCD. Let's go. Hello, GLA Summit. We go like that. I can just about see it, which isn't ideal. So I bought another one. Looks really good on my desk, but the camera don't like it. So let's have a little play with this one, which actually, with no light at all, works quite nicely. So just do the same again. Hello, GLA Summit. But you can do clever stuff. Like, so this is a bit more. This was all of about £15. Let's do that. Oh. Bonk, 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 bonk. Bonk, bonk. You're pulling in the R, the G, and the B. Yeah. And switching them out to maximum. So you got backlight. That's actually much better for presenting on videos and things. So it's a bit harsh, the lighting on the one without it. And again, that's all simple bytes into a register. It registers the bytes doing that kind of thing, which is nice. So finally, for this section, we have a gyro. Gyro. Which I don't know where I've put. Could be here. Oh no, I haven't. I've got two. I've got two more to go. So gyro, which is this kitty here. And I get very confused with gyros, CX, Y, and the Z part. It's the Z part that confuses me. So let me zoom out so we get some space. All right, let's take all of this lovely Lego away because we don't need that now. That's that. Clear the space for the gyro. Okay. Launch the camera around. Don't want to be there. So if we run that, it gives us a gyro position. Then you move it, it gives us other gyro positions. It gives you a load more. This thing is very capable, but I just wanted it to show me position. It gives you acceleration and all that kind of stuff. So it's quite a funky little beast. This kind of stuff is going to be helpful for sort of hobbyist positioning of things. I think the only place I ever used it was a laser firing things up into the sky. Significantly more expensive. There goes my camera. Okay. Finally, to Just let me set that up. If you don't want pulse width modulation and you just want an analog out, I'll wire it up while my camera's off. And then I'll turn my camera on and give you the full glory. Right, red is positive. That is negative. Okay, turn him on. Reset my goddamn camera. It's definitely overheating, I think. Something bad's happening to it. Okay, so I've got one of these little M5 stack doofers, and they do a DAC, which is a digital to analog converter. So you get two channels of 16-bit. So if I load him before my camera fails, and outs. And move him here and him here, because we don't really need to see the static bit, do we? And we'll give him 16. We'll go blump. So he's just the VI has got a loop. But you can see he's gone to 0.7 of a volt. So now if I crank him up and then go boop, it goes up to 8 volts. And you can quite easily calibrate it, but it really depends on what you've got. So there's a switch, a 5-volt switch here on the side. Can't see it. On the side of this little board that either makes it 3.3 volts or 5 volts. And this thing has got a doubler or something because it manages to produce more volts than miraculously went into it. But it's pretty stable. As you can see, that's a nice stable output and a good analog out. So that's a cool little beast. And that was pennies. I think that was like £6 for 2 channels of that. And it also comes in its Lego friendly little box, which is nice. So analog output sorted. So my plan is, and there's thousands of them, I've lost my lighting now, is to try and do as many of these as I possibly can. I'm going through the fun ones first. But there's a lot of them, as you could see. So I'm trying to fill out functionality rather than anything else. Now, is that it? Have I done everything in my I2C? I think I have. So that's all of that. And if we look at the website, my idea, is to build out all of these sensors, and you can see there's lots of them, all the ones I can. Now there's some that I can't, and this is probably a problem I leave in Derek and Tim's capable hands. So for example, I'm still going through the UARTs, so I've got a little LoRa UART device here. Still trying to fathom out what that's doing because it's got an intermediate chip, so it's not. I was expecting it to be raw LoRa, but I don't think it is. This little sensor here is a distance sensor, and that uses a pulse echo. So we might have to have a think about if we can do that. I mean, it doesn't really matter if we can't do it. We don't need it to be everything. It's just the obsessive in me wants it to have everything. The next, so, and there's just a lot to do, as you can see. But I'm thinking, most of the digital ones I can just cut and paste. I'm going to say they're done. Most of the analog ones I can cut and paste and just put a VI in. When I've done, that's all going to go up on the website, on the CTI website is open source. I mean, if anyone wants it now, I can send it to them, but I'd really like to plow through it. So what do we use this for? I'm personally building out some training, which I referred to earlier. So let's have a look. So for example, here's the state machine solution. So here is me. So I'm going to be training that as the 5th session in my training, 2-day training course I'm doing this end of the week. So the idea is you trot up with, I mean, I've charged them 50 quid for the hardware, and they get, I'm trying to get instant gratification so that each example is gives you the same sort of, ooh, I've turned an LED on type of feeling. So that's where I'm going with this. So probably after next week, I'll start publishing a bit more of this. So let's have a look. Where were we? What's next? So if I got time, I'll go through this. I don't think I'm going to get time. So I'll do a video on it. That's probably the easiest way. Essentially, it shows you how I use the Arduino and a Pigascope to hack the comms and then rewrite it back. So there's lots of looking at C code. There's lots of looking at Python code. And depending on how much abstraction they put into it's either decipherable or indecipherable. So it's either easy or hard. The next thing I'm looking at is vision. So if we look here, I'll share a little microscope glowing like the sun. Gets ISO sorted. So that little microscope, let's keep pointing at it while the camera's working, might as well, is doing interesting things. So I'm using him for, and this is John Medland's work, really. But what I'm using it for from a teaching perspective is I want to teach data types, really. So if I run this, so I've got this running on Linux as well, or John has. And so if we start, so this is not NI Vision, this is OpenCV. So here we've got 2 lines going down it. So if I take an image, you can see there's our 2 lines, and you can see there's if I go across, we should get the 2 lines. It's because I've fallen off the edge there. So if I go, I don't know, go 100. Take another image. You can see now we've got a bit more going on. We go 400. So essentially what I'm going to be using this to do is teach how to pull data out of arrays, how to convert RGBs, 32-bit data into 4-bit data, and all that kind of gubbins, and how to show graphs and things like that. So it's actually quite a nice, cheap tool to teach data. And, those are 11 quid from Amazon. It's just a webcam interface. So that's very, very good. It's a very good tool for this kind of thing, and you don't even need a microscope. It's just I thought my students would find a microscope useful. So that's vision, and again, the plan is it's already open source. The toolkit is open source, but I'll probably open source the lessons as well. I take up quite a lot of room. My repo here is full of big DLLs because it's the driver can do all sorts. You can do barcodes and augmented reality and all sorts of good stuff. So it's very cool like that. Okay. Ooh, time is moving along. Next, that's my demo for vision done. So my lab view in a box concept. turn my camera on again. This would have gone a lot more smoothly if I'd had a camera that worked, or just used a webcam. Okay. Everything's falling apart. Okay, let view the box. So the idea is to have this here hat. Hold on. Oop, pop, bing. This here hat on top of the little Radxa box. So the Radxa's it's probably about $100 by the time you've got everything, power supplies and the like. And then to get the hat on top is a board. Now this hat doesn't work. It's a Raspberry Pi hat, and because Raspberry Pis don't have analog inputs, they've got lots of extra hardware in that stops it working. So what I have done is made a little board, which, if I wasn't fiscally careful, I'd have in my hands now. But I couldn't be bothered to pay the amount that they wanted, so I'm going to get it next week. Essentially, there's not a great deal going on in the board. And if we look at the PCB, anytime today, come on. It's got an audience watching. There we go. Oh, so the PCB is going to be the same as essentially, I give hopefully the same functionality as this little board here. Because what I've done is actually transpose that board onto this board. And then that should give us all the functionality we need to have it on the board. So that really then gives me my LabVIEW in a box concept, which is I've got a LabVIEW image here, got Linux. I just give that away. There you go. Do your stuff, plug stuff in. And the reason the plugging in is important is because what worried me is if you're using a breadboard and you fritz this, you've fritzed your whole system, which is not good. So using these is essentially a bit safer because you're not teaching people wiring in breadboards, you're teaching them software. So that's my LabVIEW in a box. Exactly. In case anyone's not reading, Derek has just told us everyone what a Radxa is. It's a X86 board, but it's got a Raspberry Pi 2040 on it. And probably what you would use in this situation is that you would probably come out on a ribbon cable. It's a bit cumbersome having it on here, to be quite honest with you, but it's the easy way to deal with it. So either way, they work fine. Yeah, and it's a good little board. So and the thing is because it's Linux and because it's community edition, we can whack it on there. It's just an image that we can put on it, so we can put all the code and everything and distribute it. So distribution is the thing, and that's the thing that all this licensed sort of hardware and software stops you doing. It stops you distributing freely stuff that is better to be able to distribute. So that's cool. Let's see if that's my lot. Yes, that's the end of. Oh, there's my board. Oh, there's the latest and greatest delivery time. Start from first. Why did I start from first? I even read it. Yeah, so now I've gone through Safe PTB just because we've got a company account with them already. So you can see here it's production started due to the delivery on the next week. So it'll be very exciting, and I will do a video on it when I get it. But this is the test board, and again, I'm going to open source these KiCad drawings. So whether that all ends up on the CTI GitHub, I don't know. But it'd be quite cool to have it, I think, because it's quite useful. Questions, comments. Or can I knock off for the evening? Absolutely no questions or comments. Lovely. Did I miss anything? I think I did. How best to start what, Malcolm? What do you want? Eric, everything is Visa on these. Yeah, well done, Fab. Yeah, everything's with Visa on these. And where we can, it'll probably be Visa. But the if we ever port to something like Arduino, we probably haven't got the processing power. So this is where we would do something. There is a CTI website. Somebody else can put it in the website. But if you go to G Central, everything's there. And like I say, Malcolm, if you want these drivers, they don't take up a lot of room. I'll send it. I'll send it all your way. The firmwares, and there is a Discord. Well done, John. It's quite an active Discord. That's it. And we're all ploughing forward, and it's a completely voluntary, but we have a kind of shared vision about how all the bits fit together. So having training materials available for free, having hardware that's inexpensive, that essentially you can give away, being able to I think it's also the excitement. It's I don't want to be trained on emulated hardware. I want something that goes on and off. And you can probably see it when I was doing the demos as a simple pleasure in just things working. It's what a lot of us do LabVIEW for, is because we want software that interacts with hardware. And if you can keep it, you can do things with it. And really the scope of project work you could be doing on this, I'm not talking professional project, but sort of hobbyist project work, is quite amazing, really. For pennies, yeah, you can do something quite spectacular. And the other use that has come from doing this is these are all now part of my toolkit. So if I've got a piece of hardware I want to test, so like I had some camera work. I was doing the vision system. John can back me up on that, and I needed a trigger. I just used the relay board and a little driver that I said just to set the trigger. So it's spectacularly useful just as a toolkit of parts that you can just knock together bits and bobs out of. So I'm finding I'm reaching for this kit more and more. Let's see. I think if I go GitHub LabVIEW training, that'll be show you the GitHub page, won't it? Bop, bop, bop. Before we finish, and I probably am due just to finish. Look at that. It's almost as if I practice, which I don't. So GitHub. And Olivia's and Fabiola and everyone like that have been doing some brilliant work on the documentation. So here's the LabVIEW community training GitHub page. G Central hosting some of the bulkier items. So we've designed it so that the LabVIEW Community Edition on Linux can be loaded as a virtual machine directly into something like VirtualBox, and that's an amazing thing as well. I mean, we're beginning to get to the point where LabVIEW an install of usable LabVIEW, it can be as simple as just watching a progress bar. That's really one of our aiming points. Oh, manually operated switch was so old-fashioned, John. I might have to cut you off and not talk to you again. All right. Any other questions? You've got 3 minutes before I give up to the next one. Tick, 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 tick. How do I work out who's here? Oh, I can look. Well, thank you for your time, everyone. Splendid. Right. Well, thank you, everyone.